Started.
Let's get it started.
Okay. All right, everybody. We're the Constructed Wetlands group. We got Josh, Anthony, and myself, Gus. If you can go to the next slide. All right. So constructed wetlands are like Earth's kidneys or nature's kidneys. They filter pollutants from waterways and send cleaner water sources into natural lakes, streams, or oceans. Wetland design uses biomimicry to imitate novel ecosystems, and they can be some of the most biologically diverse and productive natural ecosystems in the world. Some ecosystem services that they provide are improved water quality, improved water holding capacities, flood protection potentials, generating wildlife habitats, and overall just a less expensive option at the end of the day than traditional wastewater treatment.
So one of the ways we looked at creating these wetlands is a Beaver Dam analog, also known as BDAs. These are man-made structures that kind of span across creek or stream systems, and they mimic the form and function of like actual beaver dams. So they're created by driving usually willow branches down into the bed of a creek or stream system. These pillars just span all the way across, and then using smaller branches weaving between these pillars, you start to create some blockage, and then using sediment and rocks on the inner side, you start to build up kind of a watertight barrier, and that starts the backflow of these streams and river systems, and it starts to create sediment buildup to create more of a watertight seal, and then it starts to combat stream incision by promoting better sediment deposition. So the benefit for these is it improves water quality, like I said, by allowing sediment to settle into the bank or the beds of the stream. It also promotes beaver reintroduction. So these are usually built in areas where beavers have kind of been pushed away. And a lot of times beavers will come back to these areas once they've realized that there's, the right conditions for them to build their dams. And so that's something that we were looking into, especially with the beavers of our area. And they also create complex egg habitats for fish. So the inner side of the BDA, it starts to pool and create deeper areas and different conditions for fish to start to lay their eggs. When we were in California with my studio, we saw this with the salmon. So salmon like to lay their eggs in slow moving water in deep areas of the water system. And so this is something that is helping the locals start to reintroduce salmon in areas where actual dams have kind of pushed them out of their local habitats. And it's also good for creating wetlands, which is the one of the main reasons we were looking at it. The backflow of the BDAs starts to reintroduce new, not reintroduce new, but reintroduce different wildlife by creating new habitats that the wetland has kind of started to produce.
And now we'll move into a few examples of successful wetland design. The first one being Kunli Stormwater Park. This is in Kunli, China, and it's viewed as a very successful large-scale wetland project within an urban area. If you go to the next slide. The site is 34 hectares and it's surrounded by a city and a river to the north. And originally this whole area used to be a series of marshlands and wetlands. And as development continued, that area started to be reduced and reduced until what it is now, or until what it was before this project. And they decided to look at this site in terms of how can it help the city and this idea of resilience. So it's used to filtrate, store, and infiltrate stormwater from the city and has greatly reduced the amount of flooding that can occur, as this area is prone to flooding seasonally. And the center of the site was left untouched because it was the only true wetland that was that is not part of the constructed design of it, but the exterior and the perimeter has been served to kind of create this barrier between these two different kinds of environments. And there's some statistics about how performative it is, and it can retain and filtrate up to 500,000 cubic meters of stormwater annually. And the water quality has been improved dramatically since this system has been introduced, and a series of bioswales have been constructed. And there's countless species of native flora and fauna that have been spotted in the park, and 20 new species of birds now using the wetlands. And it also has improved the value of the land around it and just helped provide more equitable access and spaces for the public to use throughout the city. And the second one I'll be looking at is Hunters Point South Waterfront Park. This is in Queens, New York. And New York is having a problem of rising sea levels, and looking at different ways in which they can construct to kind of change the transition from the water to the city, rather than using a lot of gray infrastructure and walls and concrete and things like that. They're looking at these things they called soft boundaries. So this is a if you go to the next slide, a large continuous park along the water that has introduced wetlands that help with flooding and help with these rising sea levels, but also creates a park for people to use. And it's pretty iconic in how, yeah, they term it this soft edge, and has this pretty irregular perimeter that has helped in the resilience against flooding and helping with the waterfront, and is built on an former industrial site. So really being able to try to help fix the soils and the water and improve the quality of both of those throughout the whole project. You can go to the next one. And this isn't introduced as our proposal. So in Knoxville, in the first part of the project, we looked at various sites along First, Second, and Third Creek, and all of these had opportunities for education of the public, reintroducing biodiversity, pedestrian interaction with these creeks, because many people don't know they exist and don't really spend much time by them because they are pretty degraded in some areas. And we have focused to hone in more on the Second Creek site that you see in the middle with the parking lot adjacent to Cumberland. There's a lot of parking garages over there, so moving parking is not that big of an issue there, and that site has a lot of potential just for engaging the public, because it would be very visible to people. And yeah, here's a closer shot of it. You can go to the next slide. And there's the creek, and that's the identified site that we are beginning to look at, with Cumberland directly next to it. And I think we really just chose this because it was a pretty large amount of land that does have a lot of potential. Some of the other sites were pretty small and sporadic and might not have been viewed by the public, but this really encourages people from World's Fair and people just walking around campus in general to really interact with the creek and have the opportunity to interact with wetland design. You can go to the next one. And this is kind of the system that we've imagined, using a combination of BDAs and terrace plantings, and using the topography and kind of using the existing circulation patterns within that area, seeing how we can create this tiered system of wetlands and planting, and really use it as an educational opportunity. For something like this to succeed, it would have to have a lot of management and maintenance efforts into it. So incorporating student organizations and not just relying on facility services to really upkeep the site and plant different things. Yeah, you can go to the next one. This is an example of how we view this system kind of working, using the BDAs and channeling the water into different areas to pool. And then one of the biggest challenges with wetlands is the opportunity for mosquitoes to thrive. But if a wetland operates efficiently and introduces the predators of the mosquitoes as well, then it does really help keep those populations down and not cause that sort of problem where people don't want to visit it because of that. And yeah, and just really help the entire Second Creek biodiversity and environment, increase the species that exist there.
All right. So in general, wetland design, it's known as an evidence-based system. We already talked about biomimicry and wanting to imitate these novel ecosystems, these natural ones that we see every day. It just makes sense to base local practices off local sources that are already occurring. Yeah, so some common traits of these plants are water tolerant, sun tolerant, quick establisher, and emergent herbaceous. Some styles that you can get into with wetland design, you could have a surface flow or a subsurface flow. Surface flows are a little slower on infiltration rates at just or a little less at 0.1 to 0.5 inches per hour, and subsurface being a little more infiltration of water being 0.5 to 1 inch per hour. You could also get a layered stacking system like the tiered system that Anthony was just talking about in our design, or you could have a bunch of different kind of connected modular wetland systems. Normally, those are like floating wetlands. And in shapes you can get into, the more corridors you have on a wetland, longer pollution holding capacities come with that, and also increased infiltration rates. And then getting into our plants that have these traits that I just talked about, blue flag iris, swamp rose mallow, ironweed, lizard tail, elderberry, just goes on to Indian grass and river oats down there, which are more of bank stabilization plants, and the ones on top being more of a water loving wetland plants. And then we just have a seasonality chart and dimensions.
Sweet. Thank you,
Great.
guys.
Thanks.
Yeah.